All right, so part 2 of this is going to be graphing your trig functions. Okay, so you guys remember graphing last year? Yeah. A little bit? Okay, so hopefully these 6 trig functions look familiar to you. Do you recognize those? What? All right, so I'm going to show you what I would write down in your notes to be very precise.
I turned in my computer contract.
Oh, finally, good. Then I should have a password.
I can use my phone.
Yeah, I'll give it to you right after notes.
Alright.
Okay. All right, so sine. Okay, so hopefully you remember that when you draw a sine, you draw 4 increments to the right. Okay, in the 4th increment, does anybody remember what the 4th increment is always going to be?
0.
Your period. Okay, not 0. The y value would be 0 on a sine function. So your period is always going to be 2 pi over b. And we'll talk a little bit more specifically about that b value in a little bit. But it's the value that's directly in front of the x. So what would my period be for this particular parent function? What's the value in front of the x? It's invisible, 1. So what's 2 pi divided by 1? 2 pi. Okay, so the period for this is going to be 2 pi, so you can label half of that as pi, and half of pi is pi over 2. Do you remember what the amplitude is?
How high it goes?
How high and how low, right? And how do we figure that out? The number that's in front of the sine function. So the number in front of the sine function is 1 in this particular case. So we have an amplitude of 1. Okay. So who remembers what a sine function looks like? Anyone? Where does it start? Where does it end? It starts at the origin. Good. Okay, so it starts right at the origin. It goes up to a max at the first increment, which happens to be pi over 2. It's going to come back and cross halfway between its period, hit a minimum halfway between those 2 increments, and come back to where it started. Okay, so when you're drawing a sine function, does everybody realize that I'm only drawing one little slice of that whole function?
Yes.
It keeps continuing on forever, and it would look like waves, like a sound wave, if I was going to zoom way out. Okay, so I'm only going to ask you to draw 1 revolution, but just realize that we're only drawing a small slice of it. Okay, let's do cosine. Cosine is really similar to sine, right?
Yeah.
Okay, so we do 4 increments. The 4th increment is our period. Same as sine, it's 2 pi over b, so what would be my parent function's period? 2 pi. Half of 2 pi is pi. Half of pi is pi over 2. My amplitude, again, is given by the value in front of the cosine, which is 1. How high and how low? Okay, who remembers what cosine looks like? Where does it start? Good, it starts at the amplitude. So we're going to start at the amplitude of 1. It's going to cross through the x-axis at pi over 2 and hit a minimum right at pi, cross back through the x-axis at 3 pi over 2, and return to its starting spot at its period. Okay, so the cosine function, when we draw it, kind of looks like a valley. See what I'm saying by that? Like if you're just drawing just that piece of it. Whereas the sine function, I always think of it as an S, even though it's a backwards S. But I remember it because sine starts with an S. Okay. All right, good there? Okay, let's go straight to the reciprocal functions. So let's do the reciprocal of sine. So what's the reciprocal of sine? Cosecant. Cosecant. So see if you can remember what cosecant looks like. So we're going to do 4 increments to the right, and I'm actually going to go 4 to the left as well because you get some funkiness with these. Okay, the period, since it is directly related to the sine, is found exactly the same way, 2 pi over b. So what would be my period for this parent function? 2 pi. So half of 2 pi is pi, half of that is pi over 2. We'll do a few in the negative direction. Okay, the amplitude again is found the same way, the value in front of the cosecant, which is 1. Okay, so I need like a 1 here. Do you remember what these amplitudes do for the cosecant? Like, what does it look like? Yeah, it looks like a bunch of parabolas, right? Okay, now, the thing that becomes very important is, let's see, how can I say this? Okay, so sine and cosecant are reciprocals, right? So basically, every value that I get here is reciprocated. Okay, so this point right here, which has a y value of 0, gets flipped and becomes reciprocated over here. So if I have a 0 point here, what is the reciprocal of 0? It's undefined, so 0 is like 0 over 1. Okay, if I flip that, that's 1 over 0, and that's a thou shalt not rule. Thou shalt not divide by 0. So I can't divide by 0, which means what's happening right here on this y-axis? There's an asymptote, a vertical asymptote. Okay, so I have a vertical asymptote at 0. Where else do I have a vertical asymptote? Okay, so any place where I have a 0 where it crosses the x-axis on my sine, that's where I have a vertical asymptote on my cosecant. Okay, so I have one at 0, I have one at pi, I have one at 2 pi. And basically it starts to look like every 2 increments. Okay, so let's draw those in there. So we have a vertical asymptote. So let's identify that in our notes so it's really clear so we remember where those always start. Where's my first vertical asymptote? At 0. So let's say at 0, and I'm going to say plus or minus, meaning like we can add or subtract, and it's every 2 increments. So what is my distance in 2 increments? It's the distance of, what'd you say? Pi. Okay, so we can say plus or minus n pi. So n being any number, so I can say basically that makes that vertical asymptote repeat and repeat and repeat. Okay, so let's draw this sucker now. So I always like to kind of star that first vertical asymptote. That was a bad star. So I know that's where my first parabola starts. It always starts to the right of it. What's that? Is there horizontal asymptotes? There's not a horizontal asymptote, but I've drawn them as, what did I call those? I think I called them like amplitude lines last year. Do you remember that? So I kind of like drew it out so we knew where those maxes and mins hit. So if you want to do that, you can. They're technically not horizontal asymptotes because it does in fact touch those spots, but that shows you your amplitude and kind of binds your function. Okay. Anybody have a question on that one? That one's okay? All right, let's do the reciprocal of cosine. What's the reciprocal of cosine? Secant. Okay. So same thing, I'm still going to draw 4 increments to the right. I will also draw 4 increments to the left. Period again. 2 pi over b. So our period for this particular secant function is again 2 pi. Okay, my amplitude, also 1. Okay, so hopefully you remember that the cosecant and the secant look very similar as well. Okay, the only difference is where do those vertical asymptotes hit. Okay, so using that same thought process of I know I'm going to have vertical asymptotes for my secant function whenever my cosine function is 0. So where is my first vertical asymptote on my secant function going to be? At pi over 2, good. Okay, so again, I'm just going to do every 2 increments. Okay, again, I'm going to star that first one so I remember where that first parabola goes. Let's list that as my vertical asymptote. Thank you. Where's the first one at? Pi over 2. Good. Plus or minus n pi, same thing, every 2 increments. Okay. And I always start my first parabola to the right of that first vertical asymptote. And if you want to use those amplitude lines that we were talking about, feel free to draw those in. Those do become pretty helpful when you have vertical shifts. Everybody doing good so far? Got 2 left. Tell me if I can move forward. Is everybody okay, or do I need to wait for a second? Good? Still not good. All right, what's my next one? We'll do the normal one first, and then we'll go cotangent. So let's do tangent, then cotangent. So let's do the tangent of x. Let's see if you remember this one. This one's a little bit different. Okay, so again, I'm still going to go 4 increments. Okay, does anybody know the period for tangent? Pi over b. Good. Okay, now, whoops. The reason that tangent has a different, sorry, I can't write and talk at the same time, has a different period than the other ones is because, so remember that tangent is y over x. Okay, so the y over x basically affects what happens with this function. So that x value that's in the bottom, anytime that value is 0, causes that vertical asymptote to occur. Well, if you think about going around the circle, the x value is 0 on that first half revolution right at pi. Okay, so it kind of splits our function in half. And so that's why it's half of the distance of the other 4. Does that make sense? Okay, but just to be consistent, when we're drawing these, I'm still going to do a 2 pi over b for this 4th increment. It'll keep things consistent for us. Okay, but if they ask you a specific question like, what is the period of tangent or cotangent, you have to use this idea. But if you're graphing, use 2 pi over b. Okay? Everybody okay with that? It's a little confusing. You might write that in your notes. I would say, actually, let's go like this. When graphing, use 2 pi over b for your fourth increment. Okay, so I'm still going to go to 2 pi. I don't like the zoom when they zoom it in. I like it to all be the same. Okay, so half of 2 pi is pi, half of pi is pi over 2. Go in the negative direction. Amplitude for tangent? 1. Still found exactly the same way. Okay, so when you draw this, you still have to show some kind of labeling in your y-axis. Okay, so we talked about vertical asymptotes. Where's my first vertical asymptote on a tangent function? When is the first x value 0? Do I need a unit circle? Pi over 2, because x value is when the y value, right? So at pi over 2, so we're going to have the first one right here. And then again, every 2 increments. Okay, so our first vertical asymptote is at pi over 2 plus or minus n pi. All right. Who remembers what a tangent function looks like? John Travolta is very good. Which arm is up? The right arm, good. Okay, so tangent, hopefully you can remember this, tangent functions, when not shifted left or right, go right through the origin. So if you happen to have like a multiple choice question of match up the graphs, that one's usually really easy to identify. All right, last one, cotangent. Can I bust this one out? Do you guys follow me? It's not letting me squeeze. All right, fourth increment. Period, by the way, is actually pi over b, so if they ask you that, make sure you know. But I'm going to still go to 2 pi on my graph. Amplitude, like every other function so far, is 1. Okay, make sure that this bubble goes to all tangent and cotangent. Okay, so cotangent looks like a tangent function, but vertical asymptotes are in a different place. Anybody want to make an educated guess where the first one is? 0. Very nice. I always remember the functions that start with c's, so cosecant and cotangent, those ones have vertical asymptotes that start with 0. Because a c is like almost a 0, if you think about that. That's how I remember it. I don't know. It works. So your first vertical asymptote starts at 0. Okay, so again, we're going to draw, obviously, John Travolta's. I hope, obviously. And what is slightly different, though? Left arm is up. So cotangents have a left arm that goes up. So cotangent and versus tangent are pretty easy to tell the difference between, just by looking. But you have to be careful about negatives, because you can turn a tangent into a cotangent just by throwing a negative out front, shifting it. Okay, you guys ready for some examples? Well, let's do our shifts before this is probably redundant information, but can I go ahead and scroll down a little bit? Everybody good with all that? Okay, so make sure you have this. I will let you use this piece on your test probably. So make sure you know where your vertical asymptotes start. Okay, so our generic form of all trig functions looks like this. I'm just going to use one of the trig functions. Which one should I use? What? Okay, sine, you guys are too slow. Bx plus c plus d. Okay, so do you realize this is any trig function? All of this stuff translates the same. Does this look familiar, or is anybody slightly surprised by a little bit of something? Does this look the same as last year? I hope you're saying no. At least for the people who were in advanced algebra last year, or advanced math 3. Okay, last year when we learned it, this B piece was like this, x plus c. So you could directly see your left and right movement. And the B was your horizontal stretch or shrink. Okay? Once you get past algebra, it is very rare you'll see that B pulled out. They usually put it inside. Okay, so in pre-calculus, they'll put that B on the inside. Okay, so I'm going to teach you how to do it that way. Okay, what does your A value tell you? The amplitude. Okay, so that's your amplitude. And if you didn't know already, that's how high or how low the function goes. Unless you're talking about a John Travolta. Okay, we need to talk about the period. P is for period. So I'm going to say period is 2 pi over b for sine, cosine, cosecant, and secant. And then what is it for tangent and cotangent? Good, pi over b. Okay, so make sure you remember that. There's a difference there. Okay, so I do expect for you to list your periods on every single graph I ask you to graph. Okay, how did the stuff in parentheses affect any function? What direction does it take our shift? The stuff inside the parentheses. The pluses and the minus. Okay, so that's your right or left shift, right? Okay, they call that in trig a phase shift. So a phase shift is in reference to a right or left shift. Oops. Left. Okay, and to find it when you have this bx plus c scenario, you always do c over b. C over b. Now, do I need to state which way goes right and which way goes left? How do I go to the right? It's a minus, right? And to go to the, what did I just say, left? So left it's a plus, right? Opposites. Okay, if you need to write that down, write it down. What do you think that D in the back does?
Up and down.
You're up and down, and we're going to call that, whoops, a vertical shift. Okay, so that's straight up D. If it's a positive D, what direction does it go? Up. Negative goes down. That's not new information, right? That works for any function. All right, so let's do a couple examples. I have a little graphing practice that I wanted to do. So for the assignment that I gave to you, it provides a graph. Okay, so I'm going to show you how to graph using the provided graph. Okay, in the past I've had you kind of create your own and do the 4 ticks to make it very consistent. So, is doing a 4 sine of x too easy, or
No.
should we do it?
Let's
do it? All right. All right, so notice in the directions it says find the amplitude, list the period, the phase shift, the vertical shift, and then also list if there's any asymptotes. Okay, so I expect for you to list that. So if I give this to you on a test, I will be looking for you listing those things. Those will be part of the points. So even if you can't get to the graph part, you can at least list, I have an amplitude of 5, I have a period of this, I have a phase shift of this. Okay, so you can still earn partial points for doing it. Okay, so tell me what my amplitude of this function is. 4. What's my period? 2 pi. Okay, do I have a phase shift? No. Vertical shift?
No.
Asymptotes? No. Okay, so if they don't have them, you don't have to list them. I'm fine with that. All right, so the period is basically telling me where my sine function is going to end. Okay, so I'm going to put a point where this is going to end. And then I'm going to put a point where it's going to start. So where does the sine function start?
0.
At 0. Okay, so hopefully you're thinking, okay, I know this kind of has that S curve, right? It's going to go up to a max, cross halfway between, which I can plot out immediately. It's going to cross exactly at pi. Okay, so I'm going to have a max point at pi over 2 up at what? What's my y? 4. Okay, what's my min going to be at 3 pi over 2? -4. Okay, so this is all that I'm really expecting you to do for a sine function. I should see 5 points, and it should look basically like an S. If you feel like you want to go further than that and keep drawing more of the curve, that's fine. Pretty easy? Should I do number 6, or is that one too easy? I mean, that's almost exactly the same as the parent function. The only difference is your John Travoltas are steeper. That's too easy, right? Too easy. Kind of same thing with number 7. That's the only difference is how low your parabolas are going, and they're only at a half. Okay, let's do 8, where we actually have a different period. See 8, we have an adjustment on our period. Okay, let's start by listing the amplitude. What's the amplitude? 1. Okay, what's my period? Okay, good. 2 pi over 2. Everybody see where we get the 2 from? So everybody agree that's pi. Okay, we have no shifts and we have no asymptotes, so you don't have to list those. Okay, so I'm going to start by plotting my ending spot, okay, which is going to end at what value? Pi. And what's my height going to be? 1, because it's a cosine function. It ends at an amplitude, right? So it's going to end right here. I know my starting spot starts where? At 1. Good. What happens exactly halfway in between these 2 points? At -1. Good. I hit a minimum. So at pi over 2, I have a minimum. Okay, and basically I know that I have to cross in between those. So it's going to cross exactly at pi over 4 and 3 pi over 4. And I only have left to draw that curve. And make sure that you do draw a curve and not a V. A V is a totally different function. Is that pretty easy? Should we do one with a shift? It's too easy for you guys. Let's do a shift. We need a shift in there. Let's do this one. That one looks good. There we go. Now we're getting some good stuff. Number 11, yeah. Let's do 11. Unless you want to do 12. Do you have a preference? Cotangents are generally a little easier just because you don't have to work so hard on the amplitude. But we could do 12 also. Alright, tell me what the amplitude is. 1/2. Ooh, what's the period? Huh? 3? The period is 3? Okay, so you're saying 2 pi over 3. What's my b value? It's not 3, it's 1/3. Because technically the b value is like dividing by 3. So 1/3, so if I have 2 pi over 1/3, that's the same as 2 pi times 3, which is Oh, who said that? It's a cotangent. Oh my gosh, you guys. So it's not 2 pi, it's pi. Good catch. Thank you. I didn't even think about that. So how about 3 pi? Good. But when I graph it, I'm going to be thinking, what? Ooh, I guess we don't want to go to 6 pi, do we? That's okay. So 3 pi. Okay, let's think about this. So 6 pi, actually, I kind of want to take that in. That would be 5 pi. Let's think about this for a second. We don't need it, but let's think about it. Okay, so if my period was in fact 6 pi, okay, so you might need your parent function in front of you for a second. Oh, hold on. Let me do the phase shift. My bad. What's my phase shift? Okay, so it's going to be 3 pi over 4, and then can I go ahead and say times, because it's divided by b, so times 3. Follow that? 9 pi over 4, which direction? To the right. 9 pi over, does that seem right to everybody? I don't like that number. I feel like I did it wrong. 3 pi over 1/3. I don't see a mistake. All right. So where does cotangent's first vertical asymptote begin? What? I heard it, I think. What'd you say? 0. Okay, so initially I would start at 0. But I have to move it to the right 9 pi over 4. So how far is 9 pi over 4? So you can think of it like this. If this one increment is pi over 2, a fourth would be half of it, right? So I can go 1 4, 2 fourths, 3 fourths, 4 fourths, 5 fourths, 6 fourths, 7 fourths, 8 fourths, 9 fourths. Right there. Right between 2 pi. Boy, that's a big shift.
Are we doing 6 pi as our period?
Well, yeah, I plotted it there, but I just started off of the starting spot. There. Okay, let's do this. So let's go back to our parent function because we need to figure out where the next vertical asymptote is. So remember when I said that it's every 2 increments? Okay, so where is my cotangent? Okay, it's every 2 increments. So on this one, it was related to my period. So in this case, we said that the period would have been pi, right? So if we think of this in direct relation for how often we see vertical asymptotes, do you see how on a cotangent and a tangent, you would see a vertical asymptote whatever your period is, the distance of your periods? That makes sense? Okay, so using that idea, I can now go back and say my period is 3 pi. So that means I'm going to have a vertical asymptote every 3 pi units. So 3 pi is, how many ticks? Let's see. 1, 2, 3, 4, 5, 6 ticks. So the next one will be at 1, 2, 3, 4, 5, 6. Almost right out there. Just past my 5 pi. Okay, so all I have to do now is draw a John Travolta. Which arm of my John Travolta is up? Left. Okay, so I'm going to draw a left one right through the center of all this. Okay, and then I can draw another one. It would be like, let's see, 1, 2, 3, 4, 5, 6. So it'd be kind of like that. What do you think about that one? Okay, do you want to do like a 12 or a 13 one that has a vertical shift, or do you want to start your homework and see where you end up and we can start the homework? I'm so shocked that you said it.